The last part of this problem wants us to go through and solve the initial value problem given an initial condition and again, two given solution functions. So the first thing we'll always do in these problems is go and find our linear combination of the two given solution functions. So our y of t is equal to a c1 arbitrary constant times e to the 2t, e to the 2t, plus a second arbitrary constant c2 times t plus 2, e to the 2t, and t plus 1, e to the 2t. All right, now we want to make sure that our y of 0 is equal to 0. So now we will evaluate this at 0. So y of 0 is c1 times the above vector evaluated at 0, which is 1, 1, plus c2 times the other solution vector evaluated at 0, which is going to be a 2, 1, and that must be equal to our given value of y of 0, which was 0, 1 transpose, which of course means that that's just a 0, 1 vector that's rotated on its side. Again, that t just means transpose. And that's just where the ij entry becomes the aji entry. You swap the subscripts on the matrix entry. All right, so now if we multiply this out and look at what we get, we actually end up with another linear system, but now it's in terms of numbers. We end up with a c1 plus 2c2 equals 0, and then the 1c1 plus 1c2 equals 1. And we can solve these by either using a graphing calculator, we can use elimination, substitution, Kramer's rule, we can go on and on. Probably easiest thing to do here is just elimination. If we subtract these two from each other, we just get that the c1s cancel out. 2 minus 1 just makes 1c2 equaling to negative 1. And now we can go back to the top equation, and if c1 plus c, actually it's the second equation, but we see that if our c1 plus c2 is equal to 1, that means that the c1 number is just the same thing as 1 minus c2. So that's 1 minus negative 1, which is positive 2. So our y of t, which is our solution of our initial value problem, is going to be 2 times the first solution vector minus 1 times the other solution vector. And now that we actually have numbers here instead of unknown constants, we can actually subtract these. 2e to the 2t minus 2 e to the 2t is just minus t e to the 2t. And then here we've got 2e to the 2t minus t minus 1. That's going to be negative t. And then that 2 minus 1 is going to be plus 1 e to the 2t. And that right there is the solution of that initial value problem. And again, you can check your work by two things. You can go back in and substitute this into y prime equals a times y. And you could also substitute in the initial condition of 0. And you do get 0 for the first entry and 1 for the second entry. So that's how we go through and solve initial value problems. We build the general solution with our two arbitrary constants, which again is called a linear combination. We then go and evaluate it at the initial value, which in this case was 0, and then set that equal to the right-hand side, which was given to us in the problem.